So we're going to do problem number 15 on homework number 1. It states a spherical wave with a wavelength of 2 meters is emitted from the origin. At one instant of time, the phase at r equals 4 meters is pi radians. At that instant, what is the phase at r equals 3.5 meters and at r equals 4.5 meters? So we're going to start by writing down everything that we know. So we know that the wavelength is 2 meters, and we know that the phase, we're going to call it phase 1, is pi radians at r equals 4 meters. And we're trying to find phase 2 at r equals 3.5 meters and phase 3 at r equals 4.5 meters. So we can use the equation for the phase difference between 2 points on the same wave, which is delta phase equals 2 pi times the change in position over wavelength. But since this is a spherical wave, we can change the delta x to delta r for radius. So we can change it around to 2 pi times delta r over the wavelength. And then, so we're trying to find the difference between 2 points, and so we can write this out as delta, or phase 2 minus phase 1 equals 2 pi times the change in r over the wavelength. And since we're trying to find phase 2, we can add phase 1 to both sides and get phase 2 is equal to 2 pi times the change in radius plus phase 1. And then we can start plugging numbers into this equation. So phase 2 is equal to 2 pi times the change in radius, so R2, forgot to annotate these, so R2, 3.5 minus 4.0 meters over 2.0 meters plus pi, and this whole thing is going to equal negative pi over 2 and then plus pi, and that equals pi over 2 for your phase at phase 2. And then you can do the same thing with phase 3. So the change in phase is equal to phase 3 minus phase 1 equals 2 pi delta r over the wavelength. And then we're trying to find phase 3. You add phase 1 to both sides, and you get this plus phase 1, and then you can plug numbers in. So phase 3 equals this minus R3 is 4.5 meters minus R1, which is 4.0 meters, over the wavelength of 2 meters plus phase 1 of pi. And this whole thing is going to equal pi over 2 plus pi, and you get phase 3 is equal to 3 pi over 2.